Hello everyone, before we proceed, let me introduce our group member first. First, Ahmad Muazzamil Irfan bin Mahzil. Second, Muhammad Afiq bin Muhammad Fairuz. Third, Asrul Qoyim bin Abdul Rahim. And fourth, Muhammad Ikmal Amin bin Arifin. And last, one Muhammad Zul Aiman bin Wan Zubir. The introduction. An orifice is a hole of any size or shape that allows fluid to be released from a pipe or from the side wall or bottom of a container, such as water tank or reservoir. The orifice can be used to estimate flow rates if the geometric properties of the orifice and the intrinsic qualities of the fluids are understood. Bernoulli equations, which assert that there is a link between the fluid pressure and velocity, is the foundation for measuring flow through an orifice. It is necessary to adjust the flow, velocity and discharge determined using Bernoulli equation to account for viscosity and energy loss. Therefore, the coefficient of velocity Cv and the coefficient of discharge Cd for an orifice should be determined for correct result. The purpose of the experiment is to calibrate the coefficients of the specific orifice in the laboratory.
For the problem statement, we are going to perform an experiment to find an orifice coefficient of discharge, or CD. The various type of flows, flow under constant head and flow under fluctuating head, respectively, can be used to determine the value of CD. The experiment's parameters and results should all be converted to the proper units and tabulated appropriately. The next step is to calculate the values of CD for the two flow condition based on the graph varying slopes. The objective is to determine a small orifice coefficient of discharge based on flow under variable and constant head.
So, for the learning outcomes, at the end of the laboratory activities, students will be able to first calculate the coefficient of discharge CD at several pressure heads. Second, identify the different coefficients of discharge CD using calculation based on the different slopes of the graph plotted.
Assalamualaikum warahmatullahi wabarakatuh. So, for our result analysis, for our group, we use two different size of orifice, which is 0.004 and 0.008 meter for orifice, and for volume, we find 5 exponent negative 3 meter cube to find flow rate. So to make our calculation more easier, we create the table to make our calculation easy. So in our table we have numbers, diameter, head, time, flow rate, theoretical discharge coefficient, theoretical flow rate, and percentage error. So firstly, we need to find experiment flow rate, which is we use the formula Q equals to V over time. So when so uh, we take number one as our sample calculation. So after we find the flow rate, experimental flow rate, we find the CD, which is theoretical discharge coefficient. Uh, the uh, the formula for CD is QC over A naught square root 2 GH, and then we find the theoretical flow rate, which is Q theoretical flow rate equals to A naught set 2 GH, and then we can find the percentage error, which is the formula is QC minus QT over QT divide by 100%. For we find the percentage error. So to compare experimental discharge coefficient and theoretical discharge coefficient, we need to make a data or a table from the data that we got from the graph. So the purpose of to be create the table is to find the gradient. The formula for the gradient is y2 minus y1 over x2 minus x1. So the data to make to find the gradient, we can get from the graph that we make when we we do the experiment. So when we find the gradient, we can find the experimental discharge coefficient, which is experimental discharge coefficient equals to gradient over A naught set to G. So to find the experimental discharge coefficient, we need to find the gradient. To find the gradient, we use this data from this graph. We get this graph when we do the experiment. Lastly, we need to plot the graph coefficient of discharge against it. So from the right video, we plot the graph by using 0.008 diameter of orifice, and from the left graph of our video, we use the 0.004 diameter of orifice.
So for the discussion, identify the different coefficients of discharge CD using calculations based on the different slopes of the graph plotted. Based on the results of this experiment, the value for Q experimental are 3.909 exponent negative 4, 3.676 exponent negative 6, 4.822 exponent negative 6, and 3.984 exponent negative 4. If the value for Q experimental and value for Q theoretical to be compared, value for Q experimental are lower than Q theoretical. This is due to Q theoretical assumed to be ideal fluid which has no energy losses, while Q experimental has energy losses. Thus, it is accepted that the value for Q experimental is lower than the value of Q theoretical. The value of CD calculated are 11.867, 13.204, 3.660, and 3.578. These losses can be due to friction, turbulence, and other factors. As for the values for CD from the different slopes of the graph. The values obtained are 33,082, 35,920, 14,698, and 14,290. The values are all more than 1. There must be errors made during conducting the experiment. Listed below are the possible errors that could have occurred during the experiment. Friction. Water encounters resistance from the orifice walls as it passes through. Due to the frictional force, some of the water's energy is transformed into heat. So for turbulence, water flows turbulently through an opening. The chaotic flow known as turbulence is what causes the air and water to mix. Additionally, part of the water's energy is transformed into heat as a result of the mixing.
For the conclusion, using the orifice and free jet flow apparatus, the coefficient of velocity and discharge may be calculated by measuring the trajectory of the water stream flowing out of the orifice, and then the course of the fluid exiting the orifice may be followed by graphing and charting the change in height per distance. As the head grows, so does the velocity. Since the two are exactly related, as previously mentioned, when the velocity is high, the fluid's trajectory extends further. Furthermore, percentage error were unavoidable throughout the experiment, but the data result may always be confirmed using the formula. Errors are unavoidable and might have occurred before, after, or during the experiment. Before beginning the experiment, students should check whether all of the equipment is correctly set up and ready to use. Thank you.